Well, today I wanted to take a second to talk about some algebraic and parametric surfaces. I was really interested in their shape, their form, and how they might be rendered, and ended up writing a small program in Python to help visualize them. This all came about because I met a man named Cleon Rogers, who's a mathematician and an amateur radio operator. One algebraic surface that was listed in Wolfram Alpha that qualifies in the Zariski category is a surface called the Calypso surface. The Calypso surface looks like this, and one of its cousins is a surface called the Calyx surface, which can also be expressed in this implicit form. Well, we head over to find out about Oskar Zariski because it would be a shame not to know more about him. And he was a quite prolific algebraic geometer, and his wiki page is a fascinating tour. He went to the University of Illinois at Urbana-Champaign for a season where I had the good fortune of being trained as an engineer. So I went back to Cleon, and he told me some more of the stuff he'd been doing, and one of his favorite surfaces is a parametric surface called a Dini surface. So we head over to find out what a Dini surface looks like, and we find out that it's a function of x, y, and z, but it's expressed parametrically. So as we vary the two parameters u and v over some range of numbers, we generate a set of x, y, z's that correspond to this map from the uv plane into x, y, z three-dimensional space. This Dini surface also has a couple of constant parameters, a and b, and I only call them constants because when we're varying over u and v, we typically hold a and b constant and ask what kind of a shape do we get, as the one we see here. With this information in hand, we could say, well, how might we write a program quickly using Python and a Jupyter notebook? And it turns out there's a plotting library, a graphing library for Python called Plotly. So we head over there and we look at some code and we get this to try to generate a starting point for a more general sort of function plotter. Then we come into our Jupyter notebook and we can, in 5 steps, make a little plotter. So I want to go through that quickly. The first step is we import the necessary libraries. And I'm going to give you a link to this at the end so you don't have to memorize this or even write it down. Step 2 is we generate the surface in x, y, z from the parametric equation in u and v. So here I've included a thing called the Dini equation, and there's a gen surface that worries about generating the mesh and finding the value of x, y, and z as we vary over u and v. In step 3, we package the surface for plotting, which is just a little bit of Python overhead, not much compared to times past. And then we create the layout for the figure itself, and the plot, which is a term of art in the Python world for the thing that we're actually going to draw on the screen. And then we interact with the plot. And we use this interact command and these widgets here to enable this kind of real-time interaction. So the first thing we can do is notice that we can, with the mouse wheel, we can zoom in and out, and we can look at the model at different apparent distances. We can also move it around with the right mouse button. And with the left mouse button, we can pan and tilt the model to get a better view of its various projections. Well, you can see that we're only sampling at 20 points in u and v to get this model, and we might want to increase that a little bit. And this shows that we get that famous shape that was from Inception, where Leonardo DiCaprio spun it on the table to have a dream within a dream. And we can also play with other parameters that change the shape, and with b set to a non-zero value, we begin to see that we can increase the number of threads on this helical-like shape, and we can also change the value of a and look at it in a different kind of view, but it always retains this helical or thread-like character. And that's basically it. This work is cataloged at this GitHub site, which is github.com, and these words, and that's it.